Okay, so I've always wanted to do this. What if I can build something like a hacking device so that whenever I just carry the device to an area where a Wi-Fi network is reachable, it will be able to automatically hack into that Wi-Fi network, or in other words, crack the password of that Wi-Fi network. So I do have a pretty good idea of how I can go about implementing it, because I can make use of tools like aircrack-ng or HCX dump tool, but I decided I should just write my own code and start from scratch, because that's like the best way to learn something, right? And one more thing to note is that it only works for WPA PSK or WPA2 PSK. It doesn't work for WPA3. But you know what? I have never seen a Wi-Fi network in my city that uses WPA3. Even my own home network uses WPA2, which is not considered to be secure at this moment. So yeah, I think it's pretty safe to assume that not all of the routers actually use the latest WPA3, at least the place I live. I'll be making use of Raspberry Pi 4, which I already have, which I used for one of my previous videos, and I'm going to write this code in Python. I'm also going to explain you every step that I'm doing so that you get to learn as well. Oh, and before getting started, I'd like to give you a quick disclaimer. This video is only for educational purposes. The whole concept or the purpose of this video is to teach you about the Wi-Fi technology and how someone around you who is in the range of your Wi-Fi network can potentially capture your handshake and crack your password if your password is weak. Do not attempt to hack unknown networks without the consent of their owners. Test it on your own network, because at the end of the day, your intention is what really matters. So with that out of the way, let's get started. Before moving on, a special thanks to the sponsors of this video, CodeGym. It's a well-known fact that the demand for Java programmers is very high and it's still growing. And obviously, as you can imagine, the salary prospects are excellent and they are among the most well-paid professionals in the IT industry. CodeGym Java University offers a professional online Java programming course that takes you from a complete beginner to a junior Java developer's role in as less as 12 months. It's a full-fledged course that involves hands-on training, assignments, mentor support, and much more. All the classes are held live on Zoom and are taught by experienced teachers who are also professional Java developers themselves. And they also offer a 100% job guarantee once you complete their course, and 95% of their graduates already landed jobs at companies like VMware, Oracle, Microsoft, Google, etc. Their goal is to make learning Java interesting, practical, and result-oriented, which is awesome because that is how programming is meant to be learned. And obviously, once you complete the course, you're also going to get a very valuable completion certificate, which is going to look really good on your resume. So if you are seriously looking to get into the IT industry and build your career in it, then I would definitely suggest CodeGym's Java University. They already have over 2 million students worldwide, and they hold a very good reputation in the EdTech industry. So go ahead, check out their Java course. The next batch starts from November 26th. The link will be in the description below. Oh, and hey, they're also providing this free webinar for Java aspirants. So if you're interested, you can go ahead and join that webinar. The link will also be in the description below. All right, so here's the idea. Here I have with me a Raspberry Pi 4 and a Wi-Fi adapter which supports monitor mode. I think this is TP-Link TLWN722N. This is the model number of this adapter and it supports monitor mode. It works very well. I've used it before. So I'm going to install this adapter on my Raspberry Pi and I'm going to make this or convert this into a Wi-Fi hacking device. So the basic idea is that I have my Raspberry Pi here and it has the Wi-Fi adapter installed in it, which supports monitor mode, which means it will be able to sniff the packets from the air and even inject some packets if it wants to. So when this device, my Raspberry Pi, comes in the range of any Wi-Fi network, for example, let's say there is a Wi-Fi network over here. This is the router. and this is the Wi-Fi network. So whenever my Raspberry Pi is taken into the range or the proximity of this Wi-Fi network, of any Wi-Fi network, it will be able to do some stuff with the help of the adapter that it has. So it will be basically able to sniff some packets from the air, some interesting packets from the air, and also inject some particular sequence of packets or frames, whatever you'd like to call it, in order to capture something known as a WPA handshake. Now, we're going to talk about WPA handshake in more detail as we move on in this video. But for now, just understand that the job of my Raspberry Pi is whenever it is taken into the range of a Wi-Fi network, it will capture or sniff some packets from the air that belongs to this particular Wi-Fi network, and it will also be able to inject some specially crafted packets into the air in order to do what it's supposed to do, which is to capture that handshake. So once it captures this handshake, which we call as the 4-way WPA handshake, we will then be able to perform a brute force attack or a dictionary attack on this captured WPA handshake. So the Raspberry Pi obviously doesn't have much computing power because it's a pocket-sized computer. Literally, this is the whole computer. So obviously it doesn't have much computing resources. So what I'm going to do instead of cracking this WPA handshake on the Raspberry Pi itself, I'm going to make use of my password cracking rig, which is formerly an Ethereum mining rig. But of course, since Ethereum moved to proof of stake now, I do not have any use with that rig, with that machine, so I'm just going to use it to crack WPA handshake. Once we capture this WPA handshake, I'm going to write some more code basically to send this WPA handshake to my mining rig, or should I say password cracking rig. So once this handshake is sent to my password cracking rig, there is some code running on the password cracking rig as well that will automatically fire up hashcat, which is a very popular password cracking tool, and it's going to feed this captured WPA handshake into hashcat so that hashcat will perform the cracking job, and it will perform either a dictionary attack or a brute force attack depending on various factors, and it will be finally able to crack the password. Now, the reason why I'm using my password cracking rig instead of just cracking it on my Raspberry Pi is because my password cracking rig has 5 GPUs, which means it's pretty fast. Trust me, it's really good at doing cracking jobs. It's really good at cracking stuff, cracking passwords, cracking WPA handshakes, whatever it is. I've actually already made a video about it, about my mining rig, how I use it to crack password hashes. So if you want to watch that, I'll leave a link to that in the description below or just in the suggested cards above. So go ahead and check it out if you're interested in that. So yeah, I guess that's the basic idea. So let's go ahead and write some code. All right, so first things first, I'm going to connect my Wi-Fi adapter to my computer and we should have it. So if I say ls USB right now, there you go. This is the USB Wi-Fi adapter. It is now connected to my Linux machine on VMware. So now if I say iwconfig, it shows here that the mode is auto. But as I said, in order to sniff packets and to inject packets, the adapter needs to be in monitor mode. So I can just go ahead and enable it right away. So in order to enable it, I'll just say sudo iwconfig WLAN 0, which is the interface name, and I'll say mode and I'll say monitor. Password, and it's done. So now you can see it is in the monitor mode. All right, so with that out of the way, let's go ahead and start writing our code. So the first step is to obviously enumerate the networks around us so that we'll get to know what Wi-Fi networks are in our range and which ones we would want to target and hack. So we can do that very simply by just listening for something known as beacon frames. Beacon frames are nothing but some packets that are sent by a Wi-Fi router in order to announce its presence. So when you open your smartphone, for example, and go to Wi-Fi, you can see all the list of Wi-Fi networks that are around you, that are available for you to connect. How do you think that your phone knows that these Wi-Fi networks are around you? It's because the routers that are installed in these Wi-Fi networks are sending beacon frames in order to announce that they're available to connect. So you can just basically listen to these beacon frames and get to know what Wi-Fi networks are around us. And not only that, we'll also get to know which cryptographic techniques they're using for authentication, what is the signal strength, what is their BSSID, or in other words, their MAC address, and all these different kinds of information. So we can listen to these beacon frames by making use of the KP module. All we have to do is call the sniff function, and we'll need to give a callback function. I'll just say Wi-Fi enumeration. We'll define that function later. And I also have to define the interface. which in my case is WLAN 0. And I'll just set the timeout as 5 seconds. Oops, there you go. Now I'll come back and I'll create a new function. I'll say Wi-Fi enumeration, which takes the packet as an argument. So now we'll actually check if this packet is actually a beacon packet by checking if it has the layer called .11 beacon. And if it does, it means that the packet is a beacon packet. So now that we have the beacon packet, we can just extract different kinds of information like the SSD, BSSID, etc. So first I'll extract the BSSID, which is nothing but the MAC address of the Wi-Fi router of that Wi-Fi network. I'll say BSSID equal to packet of .11.addr2. And then I'll get the SSID, which is nothing but the name of the Wi-Fi network. I'll say once again packet.11.info.decode. And we also need to know the channel that the Wi-Fi network is available on and also the cryptographic algorithm it is using for authentication. So I'll get the stats by saying packet of .11 beacon.network stats. So from the network stats, we can go ahead and grab the channel by saying channel is equal to stats.get channel. And we also get the crypto by just grabbing the same from the stats.get crypto. And that's it. Now we basically have the BSSID, SSID, the channel, and the crypto. These are all the information that is necessary for us to enumerate the Wi-Fi networks. Now, before we go ahead and save all this information, we also have to make sure that the Wi-Fi network is actually hackable. Or in other words, if it's using WPA or WPA2. If it's using WPA3, then this will not work. So I'll just check if WPA PSK in crypto or WPA2 PSK in crypto. So only if the crypto is WPA PSK or WPA2 PSK, we'll go ahead and save this network. So I'll save all this information into a dictionary. Perfect. Now I'll just go ahead and add it to my list so that I'll be able to save all this information into a JSON file once we are done enumerating these Wi-Fi networks. All right, now let's go ahead and actually save all these Wi-Fi networks into a JSON file. And I'll basically open up a file called Wi-Fi networks.json. I'll say f.write json.dumps networks. That's it. Now I'll just go ahead and call this function. All right, so that's the first version of our code, which should basically enumerate the Wi-Fi networks around us and save it into a file named Wi-Fi networks.json. So it's going to scan for Wi-Fi networks or access points around us for 5 seconds, and it's going to write all the captured networks into the JSON file. It did create a Wi-Fi networks.json file, which is a good sign. So for now, there's only one Wi-Fi network, which is my home Wi-Fi network. So that's awesome. So now that we know how to capture or sniff the beacon frames around us and figure out what different type of Wi-Fi networks are around us, get their statistics, get their BSSID, their SSID, and all that different kinds of useful information. The next step is to actually capture this WPA handshake that I was talking about. But before we do that, let's actually understand it a little bit more closely. So in this picture, you can see a typical four-way handshake. The reason we call it a four-way handshake is because there are 4 messages that are exchanged between the access point, which is nothing but the Wi-Fi router, and the device, which can be your smartphone, laptop, whatever it is. So you can see the first message is actually sent from the authenticator, which is nothing but the Wi-Fi router, to the supplicant, which is nothing but the device using which you are connecting to the Wi-Fi. And this message basically contains some keys. Now, I'm not going to go much deep into what these keys are and what their importance is. I'm not going to talk about the cryptography behind this, but if you want to learn about what these keys are, how they are generated, what's their importance and all that stuff, I'll refer you to this particular article that I have opened in my tab. This is a wonderful article. It shows you a lot of things. So I'll leave it in the description below in case you're interested. So anyway, coming back, there are 4 messages. Message 1, message 2, message 3, and message 4. Now, the whole purpose of these 4 messages, or in other words, this 4-way handshake, is for the Wi-Fi router and the device to agree upon something known as a PTK, a pairwise transient key. So this PTK is actually the key that is used to encrypt all the data that is exchanged between a Wi-Fi router and a device in that Wi-Fi network. So if you notice closely here, the Wi-Fi password, which is also known as PSK or pairwise shared key, is never ever transmitted throughout this whole 4-way handshake. And it makes sense because all these 4 messages are not encrypted. They cannot be encrypted because they do not have any key to encrypt with. The whole reason for this
four-way handshake is to create a key that can be used to encrypt. So initially, they do not have a key. So this handshake is unencrypted. It's plain text. Anyone who is around you can actually sniff and see this four-way handshake. So obviously your Wi-Fi password is not sent in any of these four messages. But it's not really perfect, because if an attacker captures this four-way handshake, captures all these four messages, they will be able to brute force your Wi-Fi password, because as I said, these keys that are being exchanged are related or are derived from your Wi-Fi password. So when you have them, you can eventually brute force and backtrack your way to the Wi-Fi password. And that's what we are going to do now. But that also raises a question. How long should we wait so that we can capture this four-way handshake? I mean, obviously, this four-way handshake only occurs or only happens when a device is trying to connect to a Wi-Fi access point. That is the only time when this four-way handshake occurs, and that is the only time we can capture it. So how long should we wait? We actually need to wait until some device is connecting to a Wi-Fi network so that we can listen on this four-way handshake and capture it. Well, there is a workaround for this as well. So let's say there is a Wi-Fi network here which has three devices, D1, D2, and D3. This is the access point, which is, in other words, the Wi-Fi router. So what we can do as an attacker is we can send something known as a de-authentication request to all the devices inside this Wi-Fi network, pretending to be the access point. Now, every device in a Wi-Fi network has something known as a MAC address. It's a unique address that is used to identify a particular device in a network. So what we can do is, since we already know the MAC address of our access point, we can actually impersonate the same MAC address and broadcast the de-authentication frames to all the devices. So when these devices receive these de-authentication frames, all they know is that they are originating from the access point. They do not know that we are the ones sending it. They only see the source MAC address, which is going to be the access point's MAC address, and they're going to think that the access point itself is sending these de-authentication frames. And when they see these de-authentication frames, they are going to disconnect themselves from the Wi-Fi network. Well, what good does that do, you ask? Well, every device, almost every device, has this option, or has this feature, should I say, to reconnect to a Wi-Fi network. So when we de-authenticate a device from a Wi-Fi network, it's going to try to automatically reconnect back to that Wi-Fi network. And what happens when it tries to reconnect? That's right, the four-way handshake that I was talking about earlier takes place. So we will be there to capture, to listen to this four-way handshake and to capture it to our advantage. So let's go ahead and implement that as well. I'm going to perform this de-authentication attack in a different thread, because at the time of performing this de-authentication attack, I also want to listen or sniff the packet so that I'll be able to capture the four-way handshake. In order to be able to do that, I need two threads. On the main thread, I'm going to keep listening for the four-way handshake. And then on the new thread that I'm going to start, I'm going to run this de-authentication attack. So let's go ahead and do that. So I'll call my thread as de-author. So let me start the thread. I'll put the target as de-auth attack. Arguments are going to be the AP MAC address and the channel. I'll set it as a daemon thread and I will start it. So obviously, since we are attacking all the Wi-Fi networks that we have captured and saved to the file, we have to enumerate each Wi-Fi network and perform this de-authentication attack on. So first, I'll read the contents from the Wi-Fi networks.json file, and then I'll enumerate through each network. I'll get its BSS ID and the channel, and finally its SSID, which is nothing but its name. And that should be it. So now I'll just pass in the BSS ID, which is nothing but the AP MAC and the channel. All right, so now I'll go ahead and create the de-authentication function, de-auth_attack, which takes the AP MAC address and the channel. The first thing we need to do is we need to set the channel to the appropriate channel. So I'll say os.system sudo iwconfig /0 channel followed by the channel. And then I'll just go ahead and craft a packet. And as you can see, the address that I mentioned here in this packet is FF. So this is nothing but the broadcast address. So when you mention this address, it means that this packet is going to be broadcasted, which means it's going to be sent to all the devices available out there. And then the address 2 and address 3 is going to be the AP MAC address, because we are going to impersonate ourselves as the access point of that particular Wi-Fi network. So I need to send this packet like for example, let's say 1,000 times. So I'll just start a for loop and I'll say send packet, which is the function available with Scapy. And I'll send a packet. The interface is going to be WLAN 0. And I'll just say verbose is equal to 0 so that we don't see any unnecessary information on the terminal. Perfect. So that's about the de-authentication attack. So let's go ahead and actually try this out, shall we? And if this works, all the devices that are currently connected to my Wi-Fi network should get disconnected. So even my smartphone should be disconnecting from my Wi-Fi network if this attack works. So let's see if it's actually working. Let me start the recording on my smartphone. So as you can see right now, my smartphone is connected to my Wi-Fi network. So let's start this attack and let's see if it works. Let's see if my smartphone gets disconnected. Hey, let's try that. All right, so you can see for a moment there, my phone actually got disconnected from my Wi-Fi network, and that means our de-authentication attack is actually successful. All right, so now we have to capture the handshake. Capturing the handshake is nothing but listening to the packets and then figuring out if this handshake is included in this captured packets. So we can make use of the same sniff function that we have used before, but now we'll be actually making use of it in a different way. So what I'll be doing is I'll be including a stop filter, and I'll say a callback function, let's say WPA handshake for it. So what this basically means is that for every packet received, it's going to call this callback function WPA handshake, which we will define in a moment. And once this function is executed, if it returns true, then this sniff function will be terminated. So as long as this function doesn't return true, the packets are going to be sniffed. But when this returns true, no more packets are captured. All right, so let me go ahead and define this function, which is WPA handshake, takes in the packet as an argument. So I will define a pcap writer so that I can write these packets into a pcap file. Packet dump.write packet will actually just write all these received packets into this pcap writer. So for each packet, I also want to check if it contains the ePOL protocol. The ePOL protocol is basically associated with the four-way handshake. So when we see an ePOL protocol in a packet, we know that it is part of this four-way handshake. So we'll check if this ePOL exists in this packet. So if the packet belongs to a four-way handshake, we'll just increment the ePOL count with 1. So actually, I'll define this ePOL count as a global variable here. So for every packet that has ePOL in it, we are actually incrementing the count value with 1. In a four-way handshake, we know that there are going to be 4 ePOL packets. So I can actually check if ePOL count is greater than or equal to 4, because we know that there are only 4 messages in a four-way handshake. But this is not very ideal when it comes to real life scenarios, because most of the times the messages inside this four-way handshake are repeated and we don't know how many times they are repeated. So to be on the safer side, I'll give a big number, like let's say around 10. So if there are at least 10 ePOL packets, then we'll return true, because we can be sure that the four-way handshake is fully received. You know what? I'll actually say captured equal to true here. Return captured. So I'll say if captured. So let's go ahead and see if that works. All right, so let's check if the handshake is captured. It looks like it is captured. Let me try to open that up with Wireshark. And let's see if there are any ePOL packets that are captured. And would you look at that? These are the messages inside the four-way handshake. You can see message 1 of 4, 2 of 4, 3 of 4, and 4 of 4. So we have captured the complete four-way handshake. So now since we have this four-way handshake, we can just basically perform a dictionary attack or a brute force attack offline. I don't even have to be in the proximity of the Wi-Fi network anymore. I can now just send this four-way handshake to my password cracking rig and perform the cracking job there. The way I send the WPA handshake to my cracking rig is that I have written a simple Flask server on my cracking rig, and when a file is sent to a particular endpoint, it's going to save this file in a directory, and then there is another automation script written in Python that will automatically fire up hashcat, and it will feed this received handshake file to hashcat and hence start the cracking job. It's just a simple Flask server and then an automation script that handles hashcat. Okay, so currently I'm in the process of setting up the Wi-Fi adapter on the Raspberry Pi by installing the necessary drivers so that it supports monitor mode, all that stuff.
and also transferring all the code that I've written to Raspberry Pi and making sure everything works. A quick update, I was actually able to enable monitor mode and get this stuff to working on my Raspberry Pi. You can see here, it is currently in the monitor mode, which means yes, that's awesome. That's a good news, I guess.
All right, guess what? I have finally loaded up all the code that I've written into the Raspberry Pi. I've set up my Wi-Fi adapter to work on it. Everything is fine. I mean, I did run into some issues, which I was fortunately able to fix. But for now, I can say that it's done. I am ready to test my hacking device, which I built with Raspberry Pi. And obviously, in order to power it, I cannot plug it into a power outlet because it is supposed to be portable, right? I built it so that I can carry it anywhere I want to and target Wi-Fi network. So I got a power bank with me that should be able to charge my Raspberry Pi. So let me plug it in and let's see if it works. All right, you can see the lights right there here. So that means it's powered on. So the code, everything is loaded in it. But wait, I think we forgot something, didn't we? That's right. You've got to wear a hoodie to do this hacking stuff. Otherwise, it just feels illegal. So anyway, what I'm going to do now is I am going to travel to my home. I'm currently at my workplace. So I'm going to test this device that I built on my home network. So I'm going to travel to my home. I'm going to carry this device with me. It probably can fit here in my pocket. I'm not sure. Let me try. Yep. Yep. It fits. Perfect. So I'm just gonna literally carry this device to my home and I'm gonna see if the device will be automatically able to capture the handshake and ultimately be able to crack the Wi-Fi password. So obviously I also have my password cracking rig up and running. It's running its HTTP server. It's listening for that post request to capture that handshake from my Raspberry Pi. And once it captures it, it's going to try to crack it with hashcat. So I've not tested this on my home network yet. So I am really excited to see how it's going to turn out. I really hope it works. So let's go. Okay, so I'm at my home now, and while I was in my way, the device actually picked up many Wi-Fi networks and it sent me through Discord. You can see, I don't know if you're able to see them properly, but it is able to send all the newly discovered Wi-Fi networks to my Discord. So if you're wondering how it's able to send all that data to my Discord, well, I just programmed it in such a way so that whenever it has something to notify, it's going to send a message to my Discord channel by making use of webhooks. Pretty awesome actually. It's already working. So I'm just waiting for it to actually pick up my target network and see what it can do against it. See if it can crack the password for it. So let's just wait, I guess. Let's just wait for another message on Discord to see if my network is detected and if it is able to perform the attack on it. All right, so I finally got a message you can see on my Discord. And in this message, there exists my home network, which I renamed as target network. You can see the point is that the device was able to discover my target network, which I'm going to target, which I own, my own network, and it is able to send me a notification to my Discord that it was able to find it. So since it discovered it, it should be able to automatically perform the de-authentication attack, capture the handshake, and send the handshake to my password cracking rig. Well, it looks like we got another update from the Raspberry Pi. It says right here that the 4-way handshake is captured for the following network, and you can see that it was actually able to capture the handshake for the target network, which is my home network, which I am targeting in this video. Alright, now since the handshake is captured, the Raspberry Pi is going to send it to my password cracking rig where the cracking job actually happens. So now I can just leave this place because my job here is done. The job of the Raspberry Pi is just to capture the handshake and send it to the cracking rig. So I don't have to be in this in the range of the target Wi-Fi network anymore because I've already captured the WPA handshake. So I'll just return to my workplace and let's see if hashcat is trying to crack the captured handshake, and hopefully it does. Hopefully we will be able to see the clear text Wi-Fi password of the target network which we just attacked. So let's go ahead and check it out. All right, so check this out. This is my password mining rig. I have RDP'd into it, and you can see that it has taken the captured handshake. You can see this is the name of the handshake file. It's named after its MAC address, and it has started the cracking attack. So if I scroll down, it also says that hashcat has finished. So that means the hash is either cracked or it's exhausted. But fortunately for us, you can see the status here says cracked, which means it is successfully able to crack that WPA handshake. So now that it is cracked, how do I actually see the cracked password, right? So once again, I've written a functionality so that if the hash is cracked, it is going to send the cracked password to my Discord. So I'm going to bring up my Discord here from my other screen, and you can see here, so first it says that it has started cracking job for this file, this handshake file. And then this is the command that it is executed. So it started the job at 6:55 p.m. and at 6:56 p.m., which means in less than 1 minute, it was able to crack the password. And you can see this is the name of the network, target network, and then this is the password. Yeah, I know what your dirty mind is thinking, but I really love watermelons. What can I say? Like, that's awesome, isn't it? It's awesome and also incredibly scary what people can do without you even noticing it. When a de-auth attack happens or when someone captures your WPA handshake, you wouldn't even notice it because your device is going to automatically try to reconnect to the Wi-Fi network. So it will be like nothing has ever happened, but all it takes for a hacker is to just come into the range of your Wi-Fi network for some time until he is able to capture the WPA handshake, and once he does, he can just leave that place because he now has that handshake which he can crack. So yeah, that's about it. That's about the video. I hope you liked it. I hope you liked this experiment, and once again, please keep in your mind that you should not be performing any of the stuff that I did on a Wi-Fi network that you do not own, or at least you do not have permissions to attack, right? I have done this on my own home network. So if you want to do it as well, you can try it on your home network to see how things work, to understand the concept, and just put an end to it there. Do not try to attack some random network that you do not own. So if you want to read the code that I've written, I will obviously be pushing it to my GitHub. So you can go check out the code if you want to have a closer look at it. And that's it. Thanks for watching. I hope you liked this video. If you did like this, please do not forget to leave a thumbs up below and also hit the subscribe button if you are not yet a subscriber of my channel. And while you're doing so, also turn on the bell icon to receive instant updates from my channel. So I'll see you in the next video. Until then, cheers.